In this video, we're going to go over some practice problems from chapter 1 in our textbook. And we're going to start with section 1.1 here, question 42. So we're told that the following information in this table here is going to relate the 2019 model year product line of BMW automobiles. So here we can see in this first column, we have the model, then we have the body style, weight, and number of seats for these cars here. Now, what we want to do is identify the individuals, variables, and the data corresponding to these variables, and determine whether each variable is qualitative, continuous, or discrete. So these would be quantitative ones. All right, so let's start with identifying the individuals. So remember from our PowerPoint slides from Pearson, these individuals are going to make up the objects or members of the population that we're studying. So the individuals here are going to be the model types. So these are going to be the model types of these automobiles. So we'll just say model types here. The next thing we want to do is identify the variables. So these are going to be the characteristics of these individuals in our population. So the characteristics of these model types are going to be the body style, weight, and number of seats. So we'll list these here as well. We have our body style, the weight of the cars, and the number of seats. All right. Then we want to identify the data corresponding to the variables. So the data for these variables, and what we can do is identify them separately here. We're still going to list these guys out, but these are essentially going to be the listed observations for each variable in our table. So for example, the data for our body style is going to be everything in blue here. The data for the weight is everything in green. And the data for the number of seats is everything in this orange here. So what I'll say is the listed observations for each variable. And this is in the table above. All right, now lastly for this question, we want to determine whether each variable is qualitative, continuous, or discrete. So I'm kind of running out of room, so I'm going to do that up here. So we want to look at each variable individually. So first, let's look at our body style. This one's going to be qualitative. And this is because we're looking at a classification of the individuals into the 3 series, 4 series, 5 series, and so on. All right, the next variable we're going to look at is the weight here. Now, this one is going to be a quantitative variable. We want to figure out if it's continuous or discrete. Now, this one is actually going to be continuous. And the reason being is because this is a numerical measure of our individuals here. Okay? That's what we have here for our weight for each automobile. Now, the last variable is going to be the number of seats. And as you may have guessed, this is going to be a discrete variable here. And this is because this is a countable numerical value. We can count the number of seats that we see in each car here. All right, so that's it for this question. Let's move on to question 46 here. So we're told that the Gallup organization conducted a survey of 1,018 adults aged 18 and older living in the United States. Now, on the survey, they asked if you had $1,000 to spend, do you think investing in the stock market would be a good or a bad idea? Now, of these 1,018 adults that they surveyed, 46% said it would be a bad idea. Now, this organization reported that 46 of all adults living in the United States thought that it was a bad idea to invest $1,000 in the stock market with a 4% margin of error and a 95% confidence level. All right, so with this information, we want to answer the following questions. First, we want to figure out what is the research objective here. Well, we go back to this question here. What they asked, if you had $1,000 to spend, do you think investing in the stock market would be a good or bad idea? So they want to determine what proportion of adults think investing this $1,000 in the stock market is a bad idea. So we'll write that out here to determine what proportion of adults, and the adults are 18 or older, think investing $1,000 into the stock market is a bad idea. They're trying to figure out this value here. All right. Next question, we want to figure out what the population is. This is going to be the adults, again, 18 or older, living in the United States. All right. For question C, what is the sample? This is going to be the people that are surveyed. So it's going to be the 1,018 adults surveyed. Now, for part D, we want to list the descriptive statistics. Now, this is just going to describe and summarize the data from the survey without actually making any inferences. Now, if we look back here, we're told that of the adults surveyed, 46% said it would be a bad idea. So this would be our descriptive statistics here. So, of the 1,018 adults surveyed, 46% think it would be a bad idea. And then lastly, for part E here, what can be inferred from this survey? So we can infer that a little less than half of the adults in the US believe investing at this $1,000 in the stock market is a bad idea. And we can infer this directly from the descriptive statistics that we found in part D. So I'll write that out here. So a little less than half of the adults in the US, based off of this survey, believe investing $1,000 into the stock market would be a bad idea. All right, so this brings us to some questions from section 1.2. For questions 11 and 13 here, what we're going to want to do is determine whether these studies depict an observational study or an experiment. Now, if you recall from the Pearson lecture slides, an observational study is going to be observing behavior of individuals without actually influencing the outcome. Whereas an experiment here, in this case, a researcher may change the value of what's called our explanatory variable and record the value of our response variable. So definitely make sure you're looking at the PowerPoint slides and the textbook for this vocabulary here. So, for question 11, we're told that seventh grade students are randomly divided into two groups. One group is taught math using traditional techniques, while the other is taught math using a reform method. So, after 1 year, each group is given an achievement test to compare their proficiency. So, just based off of this information, we should be able to tell if it's an observational study or an experiment. Now, in this case, this is going to be an experiment. Now, the reason being is that our teaching method in this case is going to be the explanatory variable, and the teaching method is going to change. And what we want to do is observe how it affected the proficiency, and the proficiency is going to be our response variable. So we'll write that out here. So the teaching method, which is going to be our explanatory variable in this case, which I'm just going to abbreviate with this EV here. Is changed. So we have multiple teaching methods. We have the traditional techniques and the reform method. So the explanatory variable is changed to observe how it affected the proficiency. And in this case, the proficiency is our response variable, which I'm going to abbreviate with this RV here. All right, so that's an example of an experiment. Let's look at question 13. Now, in this case, we're told that a survey is conducted asking 400 people, do you prefer Coke or Pepsi? Now, in this case, this is just going to be an observational study. We're not changing the value of an explanatory variable and trying to record the response here. We have no outside influence. So we're just asking this question, do you prefer Coke or Pepsi? So I'll say that here we have no outside influence. All right, let's look at question 18 here. We're told that researchers asked 93,676 women to disclose their coffee drinking habits and also determined which of these women had non-melanoma skin cancer. The researchers concluded that the consumption of six or more cups of caffeinated coffee per day was associated with a reduction of this non-melanoma skin cancer. So, with this information, let's answer the following questions. For part A, what type of observational study was this? And we want to explain that. So, in this case, this is an example of a cross-sectional observational study. And this is because the researchers are collecting information about the individuals at a specific point in time. So, that's the exact definition of this type of observational study. So, we'll write that down here. This is cross-sectional since the researchers collected information about these individuals at a specific point in time. All right, for part B here, we're looking at, or we're trying to figure out what the response variable and the explanatory variables are in this study. So the response variable, which I'll continue to abbreviate with this RV here, is going to be whether or not these women have this non-melanoma skin cancer. So and then our explanatory variable, EV here, is going to be the amount of coffee consumed, and in this case, the amount of coffee consumed daily. All right, so our explanatory variable is the amount of coffee consumed daily, and the response to that is whether or not these women have this non-melanoma skin cancer, since in this study, we're trying to find the association between these two. All right, and then in part C here, we're told that in the report, the researchers stated that after adjusting for various demographic and lifestyle variables, daily consumption of six or more cups was associated with a 30% reduction or reduced prevalence of non-melanoma skin cancer. So we're asked, why is it important to adjust for these variables? Now, the adjustment was needed for these variables as these other outside variables could influence both coffee consumption and skin cancer risk. For example, maybe if you are older and have a more demanding job, your coffee consumption is going to increase. So we'll write this down here. This adjustment was needed as these other variables could influence both coffee consumption and the skin cancer risk. For example, the demographic variables could influence this. So skin cancer risk here. All right, so this brings us to section 1.3, where we're going to be obtaining simple random samples using this random numbers table here. So let's start with question 10. We're told that a community college has 7,656 students currently enrolled in classes. To gain the students' opinions about an upcoming building project, the college president wishes to obtain a simple random sample of 20 students. So what he's going to do is number the students from 1 to 7,656. Now, the president's going to close his eyes and drop the pen on this table here. And let's say it points to the digit in row 11, column 32. So we're going to use this position as the starting point, and proceeding downward, determine the numbers for the 20 students will be included in this sample. So our starting point is going to be, let's highlight this here. So digit in row 11, column 32. So row 11 is here on this table, and column 32 is going to be right here. So this number that we're looking at is going to be this guy. Now, when we're obtaining a simple random sample, there's a few things that we have to keep in mind. The first thing is that we're looking at students that are numbered from 1 to 7,656. So the numbers, or the maximum amount of digits that we're going to have in this number, is going to be 4. So what we're going to do is just pick 4 digits from this large number here. So 4 digits is going to give us 2,869. This means the first student in the first student selected in our random sample is going to be the student who is numbered this 2,869th student. Now what we're going to do is continue this process going downwards. So the next student we're going to select is going to be the one numbered 5,518. The next one is going to be numbered 6,635, and so on. So we'll take this one. Now notice for this one here, if we were to look at 4 digits, this would be 8,906. But remember, we only have those 7,656 students here, so this guy is not possible to select someone with this number. So let's highlight this guy in red here, just to emphasize that we're not going to select this one. And this is because, we'll write it on the side here, this guy is greater than the amount of students that we actually have, so we can't select this guy. All right, let's continue with this process though. The next number here that we can select, taking just 4 digits, is going to be 603. So then the next one we're going to select is the student in the 2,654th place, and so on. Now, again, we run into this issue here where this number, the 7,783, is bigger than our 7,656, so we're not going to select this for our random sample. So far, let's see, we have 8 students selected, but we need to pick a random sample of 20 students. So to continue this process, we're going to go to the row to the right here and proceed in a similar fashion. But instead of selecting the last 4 digits here, when we move on to this row, we're going to select the first 4 digits. So the next student that we're going to select is going to be the one numbered 4,080. The next one is going to be 6,621, and so on. Now, again, we run into this issue where this guy is greater than the amount of students that we have. So we're going to highlight it in red, indicating again that we're not going to select it for our random sample. Now let's proceed in this fashion here, just highlighting these first 4 digits for all of these guys. And then this last one here, the 662nd one, I believe concludes our random sample for 20 students. Okay, perfect. So what we're going to do is write down our sample. Our sample is going to consist of the student who's numbered 2,869 all the way through the student numbered 662. So I'll write it in that order as well, the order that we selected it. So this is our first one, our second, and so on. And then continuing this process here, we do have kind of a big random sample of 20 students. We're almost there. And then our last student is going to be the one numbered 162. All right, so this is going to be our random sample, and that is how we obtain this sample using this random numbers table. Now, for the next problem, question 16 here, we're going to do something similar. So we're told that the owner of a private food storage is concerned about employee morale. So she decides to survey the employees to learn about the work environment and the job satisfaction. So we're going to use table one, which is the random numbers table that we just used, to obtain a simple random sample of size 5 from the names in the given table. So this is our entire population here. We want to obtain a simple random sample of 5 of these employees. So the first thing that we're going to want to do is number these guys here. So just like we saw in the last example, all of the students for that community college were numbered. So we're doing the same thing here. All right. So in this case, we're not told what our starting position is, but let's say we're going to start at row 5, column 8. All right, so that's going to be our starting position. We'll use a different color for this one. We're still going to use the same table. So if we're starting at row 5, that'll be here in green, and then column 8 is going to be here. So that position is going to be this guy. Now going back to this here, our entire population only consists of 29 people. So we're going to look at 2 digits when we're selecting our numbers from this random number table. So our starting point is this guy, but we're only going to select 2 digits from this number. So we're going to take that 9 there. Now the next one here is 58. And again, that's bigger than our actual population. Our actual population consists of 29 people. So we're not going to select that one for our simple random sample. The next one that we have here is 12, 6, and then we run into this issue again with 49 and 72. And in fact, we run into this issue for the next several numbers. But then we have a 16 here. We run into this again with this 90 and 99. And then something to note here, this next number is just a 9. Now we could include this in our simple random sample because we have 29 people. But remember, the first number that we selected was also a 9. So we're not going to take the ninth person again. So we're going to highlight this one in red as well. But we only need one more person for our simple random sample of 5 people. So that'll be the person who's in the 17th position in our table. So our simple random sample is going to consist of the ninth, 12th, 6th, 16th, and 17th person here. So we have 6, 9, 12, 16, and 17. This would be our random sample, and I'll list that here. So this is the sample of people that this store owner is going to survey to figure out more about the work environment and job satisfaction. Moving on to section 1.4 here, we're going to start with question 28 from our textbook. So to predict the outcome of a county election, a newspaper obtains a list of 945,035 registered voters in the county and wants to conduct a systematic sample. So we're not looking at a simple random sample in this case. This case with a systematic sample, our population is known. And we know that that is this quantity here. So for part A, we want to determine K if the sample size is 130. Now remember, K is going to be this value here. We have capital N over lowercase n. It's going to be the ratio of the entire population N to the sample size lowercase n. So just to be clear what these values are. All right, so we want to figure out what K is. K is going to be this ratio. Plugging this into our calculator, we're going to get this number here. And then we're just going to round this to the nearest whole number. So we're going to round this to 7,269. So this is our K value. Now for part B, we want to determine the individuals who will be administered the survey. Now in this case, in order to figure this out, we first need to randomly select a number between 1 and this K value. So let's write that down. We'll randomly select a number between 1 and K. Now, the reason why more than one answer is possible is because you might randomly select different numbers, and that's fine. For this one, I'm going to select 1800. That's going to be our random number between 1 and K, which is 7,269. Now, our sample then is going to consist of that starting point, that 1800. And to find the next individual in this sample, we will add 1K to our starting point of 1800. Now, to find the third individual in this sample, we can take whatever this value is and just add another K to it. So we're increasing in increments of this K value. So we can write this out as 1800 plus 2 of these Ks. Now we'll continue this process up to, we'll still have this 1800 value plus 1 less than our sample size times K. Now, the reason why we have this n minus 1 here is to account for everything here. Our sample size needs to consist of our n value here, and in this case is 130, and this is our starting point here. If we had 1800 plus n times k, we'd have one extra individual within our sample. So we're accounting for that by this n minus 1 here. So to find the actual sample here, we'll start out with 1800, and then our next individual, we're going to add this 7,269 to 1800. So this will give us 9,069. Then we do the same thing. We'll add 2 times our K value to 1800. We're going to get 16,338. Now repeating this process all the way up to this last individual in our sample here, the 130th sample. We're going to have 1800 plus n minus 1 times k. So this would be 129 times k plus our 1800. So this would give us, we're going to emphasize that with our dots there. This is going to give us 939,501. So this would be the last individual out of this population here that is going to be in our systematic sample. All right, let's look at question 29 here. So we're told that the mathematics department at a university wishes to administer a survey to a sample of students taking college algebra. So the department is offering 32 sections of college algebra, and each section is similar in class size and makeup, with a total of 1,280 students. So they would like the sample size to be roughly 10% of the population of college algebra students this semester. So we're going to answer a few questions. The first, how might the department obtain a simple random sample, a stratified sample, or a cluster sample? And which method do you think is best in this situation? So for this problem here, what we're going to be doing is kind of just jotting down the procedure for obtaining these different types of samples. So the first thing that we have to note, though, is that the department would like the sample size to be roughly 10% of their population. Well, we know the population is going to be this 1,280 students. So they're going to want to survey 10% of that. 10% of this total population. And we can find that by multiplying 10% by this population here. And so this would give us 128 students. So just keep that in mind here. Now what we're going to do is jot down the procedure for each type of sample here. So the first one is going to be a random sample. So we've seen this in section 1.3. The first thing that we're going to want to do is number the students from 1 to 1,280. So it's our total population there. So that's our first step. Now our second step is to use our random numbers table that we saw in section 1.3. We're going to pick a starting point on this table. So pick a starting point on the random numbers table. and proceed selecting our sample. So we're going to proceed selecting the 128 students as seen in section 1.3. So that's how we would obtain a random sample in this situation here. Now we want to write down how we would obtain a stratified sample. So let's write this here. So we're going to do the same thing. We're going to kind of just list out a procedure here. And the whole point is so we can look at the differences for these different types of samples. So with a stratified sample, the first thing that we need to do is divide the population into its strata. So what we're going to do in this case, so we'll divide our population into its strata. Now, in this case, would actually be easiest to divide our population into 32 sections or the 32 classes that we'll have for college algebra. So we're going to divide our population into 32 sections, and this is going to be our strata. Mhm. Now, the second step here is so since our class sizes, as mentioned here, are similar, what we can do is we can randomly select 4 students from each class to be included in the sample. Now, the reason why we're selecting 4 is because if we take 4 from each of our 32 sections, that'll end up being 128 students. And we want to generally take the same amount of students from each section in this case, or the same amount of individuals from each strata when doing a stratified sample. So let's write that down here. So we know the class sizes are similar, so we can randomly select 4 students from each section. And again, the reason why we're selecting 4 is because 4 from each class, so 4 times 32 is going to give us the total 128 individuals in this sample that we are looking for. All right, so that's how we would obtain a stratified sample. And lastly, we want to figure out how we would obtain a cluster sample. So we're going to do the same thing here. So let's start this nicer. To get a cluster sample, the first thing that we're going to do is treat each section as a cluster. So each section is going to be treated as a cluster. Now, the second step here, what we're going to do is we're going to randomly select a few different clusters and include everyone in those sections into this sample. Yeah, so we're not randomly selecting individuals, we're randomly selecting these clusters, or in this case, these sections of college algebra. Let's write this down here. So let's randomly select a few clusters. And what we're going to do is include all the students from the clusters that we selected in the sample. All right, so that's how we would obtain a cluster sample for this given scenario. And in the textbook, there's a nice little diagram that kind of shows the different ways to obtain these different samples here. So definitely go check that out if you're struggling with any of these differences. Now, the last question here is which method do you think is best in this situation? Now, the best method is definitely going to be this stratified sample. In this case, it ensures that students from each section are represented. We're just taking 4 students from each section, so that's nice. For the random sample, this one might miss differences between sections. We're not going to get the same amount of students from sections by doing a random starting point and randomly selecting using our random numbers table. We might get several students from one section and none from another, and so on. And then the reason why the cluster sample isn't best in this scenario is that it might introduce bias, kind of similar to the random sample, especially if selected clusters are not representative of the overall population. So I'll write that down here. We'll say this is going to be the best method. It ensures that students from each section are represented. Now, in section 1.5, we're going to be looking at bias in sampling. So for the next two questions, what we're going to do is determine the type of bias in these particular scenarios and then suggest a remedy. So for question 6, we're told that the village of Oaklawn wishes to conduct a study regarding the income level of households within the village. So the village manager selects 10 homes in the southwest corner of the village and sends an interviewer to the homes to determine this household income. Now, in this case, we're looking at what's called sampling bias. Okay? Only homes in the southwest corner have a chance to be interviewed. So let's write that down here. Only homes in the southwest corner. So only these homes have a chance to be interviewed. So this is excluding pretty much everyone else. Now, what we can do to remedy this is we could obtain a stratified sample. So, since households in the same neighborhood usually have similar incomes, if we obtain a stratified sample, we can make the neighborhoods the strata. So, we'll say this. So, making the neighborhoods the strata. That way we get to hear from different households in different neighborhoods. We have more of a variety in our sample. Now for question 16, we're again going to determine the type of bias that we see and suggest a remedy. So to determine the public's opinion of the police department, the police chief obtains a cluster sample of 15 census tracts within his jurisdiction and samples all households in the randomly selected tracts. So uniformed police officers go door to door to conduct this survey. So in this case, we have what's called response bias. What's happening here is that people may not respond honestly or at all to uniformed police officers. So we don't have a good idea of what their actual responses would be. So we'll write this down here. People may not respond honestly to uniformed police. All right. And then a remedy in this case, a third party should administer the survey. All right, for the last question in this section, we're looking at question 26 here. So in the federal government's current population survey, the response rate for 10 to 29-year-olds is 85%. And for individuals at least 70 years of age, it is 99%. And why do we think this is? So why do we think there's such a difference in the response rates here? Now, in this case, this is an example of non-response bias. There's a higher chance that individuals at least 70 years of age are going to be at home when an interviewer conducts the survey, whereas people aged 10 to 29 most likely won't be at home. So I'll say this. is an example of non-response bias. Um, there is a higher chance that people aged 70 years or older will be at home um, when an interviewer conducts this survey. All right, so yes, that was an example of non-response bias, where certain groups are less likely to respond than others in a given population. This brings us to our last section in this video. We're going to be looking at question 10 from section 1.6. So, a pharmaceutical company has developed an experimental drug meant to relieve symptoms associated with the common cold. So, the company identifies 300 adult males, 25 to 29 years old, who have a common cold and randomly divides them into two groups. So the first group is given the experimental drug, while the second group is given a placebo. So after 1 week of treatment, the subjects report whether they still have cold symptoms or not. So for part A, we want to determine what the response variable is in this experiment. Now, the response variable is going to be what is observed. So that would be the proportion of subjects who still have a cold. All right. Now, for part B, we want to think of some factors in the study and figure out how they're controlled. Well, some factors are going to be gender. We are surveying men in this experiment. Another factor is going to be age and our drug intervention. We're surveying males aged 25 to 29, and we're looking at how this experimental drug will help with the effects of the common cold. So what we're doing in this case to control these factors is we're fixing the gender and age of our subjects and the amount of treatment. So these factors are controlled through fixing gender and age, and the amount of treatment. All right, for part C, what are the treatments and how many treatments are there? So the two treatments that we're looking at is the experimental drug that's given to group one, and the second is the placebo given to group two. So there are two treatments. Now, for part D, how are the factors that are not controlled dealt with? For example, we can't control who gets which type of treatment, the experimental drug or the placebo. But if you remember, what we're going to do is randomly divide our subjects into two groups. One group's going to be given one type of treatment, while the other is going to be given the other type. So we control this factor by randomizing who gets which treatment. All right. Now for part E, what type of experimental design is this? This is going to be called a completely randomized design. Now in this type of experiment, the subjects are assigned to treatments randomly. So that's exactly what we have here. So completely, let's write this nicer. And lastly, for part F, we want to identify the subjects of this experiment. Now, the subjects are going to be the individuals getting the different types of treatment. So these are the 300 adult males aged 25 to 29 years old. who have the common cold. All right. So that's how we would answer these types of questions given an experimental of this type here. All right, so that'll be it for this video.